Hey everyone, welcome to our presentation on our team's causal risk assessment evaluating current mitigation strategies for key risks impacting Australia's horticulture industry and how this affects global food security risk. Australia's horticulture industry plays a vital role in delivering products and services that not only ensures national food security, but also enhances the nation's quality of life. However, the current global horticulture industry is faced with several key risks that are putting increased pressure on Australia's food supplies, with risks including climate change, government regulations, and price/market fluctuations. Australia is a major food trading nation, with Australian food production and outcomes of agricultural research contributing to the diets of up to 400 million people worldwide. Therefore, the risks on Australia's horticulture industry play a major role in overall risk on the world's food security levels. Australia is currently taking several initiatives to mitigate these risks. However, with the world requiring an increased food production of 70 to 100% to feed a global population of 9 billion by 2050, it is uncertain how effective these initiatives are.
The purpose of this project was to investigate the problem of these key risks impacting Australia's horticulture industry and how a causal risk assessment will assist in addressing this issue. During investigation of the key risks, mitigation strategies were identified and evaluated based on their impact on the horticulture industry and thus overall global food security. Data retrieved from the literature was used to construct a Bayesian network to perform a causal risk assessment of these variables. Sets of mutually exclusive states were identified for each variable in the network, and no probabilities were specified based on our research. In order to ensure viability of the model, the network was tested using different methods, including deseparation tests for structural testing and sensitivity analysis for model behavior testing. Following review of the model based on these tests, it was then used to evaluate the impact of the mitigation strategies on global food security. This led to a range of findings, and we have developed recommendations based on such discoveries. As described earlier, the three key risks that were identified from our research include climate change risk, political risk, and price risk. The corresponding mitigations strategies for these risks include climate change agreements for climate change risk, multilateral trade agreements for political risk, and price hedging for price risk. These will now be discussed in further detail. Firstly, political risk in the form of changes in trade was identified as a key risk to the horticulture industry due to the impact it can have on food availability. Political conflicts and opposition to trade can be seen as highly disruptive on trade and supply of horticultural products. For example, bans and disengagement in trade can significantly impact the global supply and availability of food. Every country in the world is more or less dependent on trade in order to fulfill its overall food needs. Whilst various countries are strong domestic growers for certain types of produce, most countries rely on the import of horticultural goods for food security due to the ability of fruit and vegetables to be grown more efficiently and cheaply elsewhere. A mitigation strategy of holding multilateral trade negotiations was chosen. Multilateral trade negotiations involve detailed rounds of discussion and bargaining on trade topics, predominantly on tariffs between member nations of the World Trade Organization, known as the WTO. These negotiations are seen to have global impact as they involve over 150 contracting countries, who must all abide by the actions that are agreed upon during the round. As one of the main goals of the WTO is to increase global trade, its effect on food security through the hypothesized increase in availability of food from such agreements was therefore evaluated.
One of the greatest challenges in today's society is to provide for increasing human nutritional needs whilst coping with toughening resource constraints and the rapid transformation of the Earth's natural systems resulting from climate change. In order to keep up with the world's ever-growing population, action towards reducing Australia's carbon footprint is necessary. According to the Australian government's quarterly reports, emissions are nearly 6% higher than they were in 2005, with the removal of the carbon price in June 2014, leading to increased emissions every quarter. Therefore, it is critical that current mitigation strategies in place require constant monitoring and research to create a sustainable future. This key variable will therefore be evaluated on the effectiveness of current climate change strategies to produce alternative solutions or improvements.
According to the Australian Bureau of Statistics, agriculture can be seen as one of the most volatile sectors in Australia, with horticulture being one of the two main agricultural industries. Price volatility directly affects the ability for sellers and consumers to access and source food supplies, as food accessibility is one of the key components that make up food securities. Changes in price can therefore be seen as a significant risk. It can just be seen as essential to manage price risk in order to maintain the future success of horticultural industries and achieve global food securities. To mitigate this risk, price hedging has been chosen as an appropriate strategy. A perfect hedge can protect price levels from market fluctuation, maintain stability.
When pulling together all of our research, we developed a Bayesian network to illustrate a dynamic hypothesis detailing the relationships between these key variables and how these relationships affect the pressure on Australia's food supplies. In particular, the 2011 GrowCom report was extremely useful when we were mapping out our cause and effect, as the study provided us with an informed summary of Australia's food security, explored future-related scenarios and the threats or opportunities they pose, as well as recommendations for food security strategies for adoption. From this analysis, the network structure therefore comprised of three main components on the topic areas related to the strategies. These three components represent cause and effect within their topic. We therefore parameterized our model with probability sourced from data within our research, as well as our assumptions drawn from the various sources. In order to validate that the model was connected and working as per our research, structural tests using D-separation were undertaken to assess the dependence of the variables. Within this testing, all three serial, diverging, and converging connections were found without error. On the climate change side of the diagram, the probability of limiting global temperature increases from pre-industrial levels to 2 degrees, and an occurrence of a severe weather event are dependent upon the world's ability to stabilize greenhouse gas concentrations to roughly 450 parts per million equivalent by 2050, therefore posing a risk to horticultural production. The data on occurrence of extreme weather events was sourced from research that has mapped extreme global events to draw analysis of human-caused climate change. From research by the Global Carbon Capture and Storage Institute, the stabilization of CO2 emissions can only be achieved through implementing mitigation strategies such as energy efficiency, renewables, nuclear, solar thermal, and carbon capture and storage, of which our model demonstrates.
Identified variables in the political component of risk include whether or not governments in power were supportive or non-supportive of trade. This impacts the number and extent of tariffs placed on imported goods and whether or not free trade agreements are established. Current news reports reflect this, seen by the 2018 USA and China trade war. Due to political conflicts between the USA President Trump and China, significant increases in tariffs between the countries has added to a total of over $100 billion worth of tariffs imposed. Decreases in trade have resulted from these activities. Therefore, tariffs and the presence of free trade agreements affect the number of exported goods, and thus impact food security risk based on the availability of food. Tariffs were also seen to impact the horticulture production price, and it should be noted that a non-applicable, or NA parameter, was included in the exported goods node, as there cannot be the scenario of a free trade agreement in place while simultaneously raising tariffs. As discussed, a mitigation strategy of holding multilateral trade negotiations was chosen. As one of the main goals of the WTO is to increase trade by lowering levels of tariffs around the world, this mitigation strategy directly impacts the tariff variable. This is supported by published text from the WTO outlining significant reductions in tariffs across a range of goods after each round. The most recent concluded multilateral trade negotiation, known as the Uruguay round, saw reductions across various agricultural products, including fruit and vegetables that comprise the global horticulture industry. Furthermore, a committee on agriculture was established in order to ensure and evaluate implementation of commitments negotiated in the round.
In the price component of the network, we explained that supply level influence change in production price and the amount of wood exported, ultimately affecting food securities. Price is also affected by variations in tariff, impacting the cost for food retailers, which also affect food security risk through altering the affordability for consumers. Our network demonstrates how implementing hedging can mitigate that price risk. As mentioned, hedging strategies were chosen to mitigate price risk. Price hedging is a strategically using instruments such as future contracts in the market to reduce or avoid market fluctuations and ultimately offset the risk of any adverse price movements. Therefore, the mitigation directly impacts the cost for import retailers, and it acts as a tool to keep price stable. With our research, we were unable to source any validator on the adoption rate of price hedging as a strategy. So, for the purpose of this project, we have assumed the probability of there is 50% chance of derivative contracts being implemented. 3 different scenarios were stated to measure the effectiveness of mitigation strategies and the impacts on key variable relationships. In the first scenarios, implementation of hedging strategy changes the cost for imported retailers to remain stable. However, as mentioned earlier in the presentations, the world now requires an increased food production of 70 to 100% to feed a global population of 9 billion by 2050. This means even if the export amount remains stable, there will still be a degree of risk on global food security as the new demand will not be met. This strategy can still be seen as effective due to its implementation reducing high risk level on global food security by 9.66%.
In the climate change scenario, the implementation of climate change initiatives decrease the likelihood of extreme weather events occurring, resulting in increasing horticultural supply and price and overall decreasing the risk on global food security. The probability of global food security being at low risk increases by 8% from this mitigation method, and therefore this strategy can also be seen as effective.
In this scenario, the implementation of multilateral trade negotiations resulted in a decrease in tariffs and therefore a decrease in global food security risk that high tariffs were seen to pose. The probability of global food security being high decreased by 2.66%, and the probability of global food security being low increased by 4.1%.
Overall, from data in the following sensitivity analysis table, all mitigation strategies decreased the risk of global food securities. However, price hedging strategy is the most effective form of mitigation, and it can completely eradicate high risk on global food securities. This sensitivity to finding was conducted to evaluate the effectiveness of all 3 mitigation variables on the global food security node. Based on the results, as mentioned, the hedging strategies had the most impacts on global food security with 8.22%, followed by climate change with an impact of 1.61%, and finally multilateral trade agreements with an impact of 0.673%.
In conclusion, either individually or combined, these mitigation strategies reduce different aspects of global food security risk. In this model, hedging was seen as the most effective form of mitigation as it has the highest percentage of effect on food security on the food security node. The following conclusions and recommendations for policymakers can be proposed. Firstly, governments should campaign for and adopt regulations to promote hedging activities. Implementation of a hedging mitigation strategy appears to significantly affect the price paid for the import retailer, thus increasing consumer ability to purchase food. Secondly, a hedging strategy is not sufficient for addressing global food security when applied alone. The 2 major components of global food security have been outlined in the model as consumer ability to purchase food based on price and the amount available. Hedging does not affect the amount of exported goods available and would therefore need to be implemented along with a strategy to mitigate lack of goods available. Finally, depending on the current situation of food availability, governments can consider prioritizing climate change mitigation over multilateral trade agreement mitigation when considering these 2 strategies. Climate change appears to have a greater impact on both horticulture export volume and global food security. In an optimistic scenario, 3 strategies can be applied simultaneously. This generates a greater change in global food security where it changes the probability of high risk to 0, increases the probability of low risk to 46.5%, and reduces the probability of medium risk to 53.5%. Thank you for listening.